Cool. So, welcome everyone. Today we're gonna talk a little bit about sort of C++ specifically, and then also get started building our sort of first game project. If you're familiar with other programming languages, this might seem a little bit easy in some sense. But if you're new to any programming language or you're just taking your first steps, this is essentially a way for you to get started with how to think about approaching programming or coding in general, and what's the right approach. A little bit about myself. So my name is Mayank. I'm the founder of Outscal, and predominantly we are an education focused company, and we help in getting students right kind of career opportunities through various programs that we have. Predominantly we work with a lot of students in the working professionals, right? People who have already graduated and are currently working in the industry, anywhere between 0 to even 5 years of experience range. And we help them sort of upskill themselves in whatever vertical that they're focused in. So mainly we are focused in two technical verticals. One is game development and another one is web development. And this is our first time trying to venture into more college space, where we feel that while folks are in colleges, they should have the right tools at their disposal to learn things early on, before things start becoming so bad that people who are graduating, they don't have good job opportunities. And it's not because they don't have opportunities, because there are not enough opportunities in the market, but it's actually very much reverse, right? There's so many opportunities in the market, just that the demand for talent is high in terms of skill. So companies are demanding people with a lot more skill nowadays than what it used to be in the past. And as a result, students need to amp up their sort of skill level in order to crack into good companies as well. Okay, so let's get started. Let me share my screen. 1 second. All right, cool. So hopefully you guys can see my screen. Let me open the chat window on the side. Okay, cool. So I think most of you would have seen sort of the Google Classroom. If you haven't joined, just reach out to the team and they'll give you access. But more or less, you guys would have seen the Google Classroom setup and would have heard of this term called project-based learning, right? So essentially what we are trying to do here is that I fundamentally have learned a lot through doing projects in my 10 plus years of professional career. And this is predominantly how I have learned, and how even my master's program in US was, in the entire 2 years we ended up just doing project after project after project after project. And it's like the most sort of intense and the best way of learning anything. So even if you don't like C++ or already know and find the session kind of not interesting because you're past that stage and you've learned the basics and the fundamentals, one key takeaway for you as a person who wants to grow into the development and the coding space is that you want to be laser focused on doing projects, right? So whatever you're trying to learn, whatever you're trying to build, try to explore what kind of projects you can do in it, right? Because that's the only way to develop your sense of curiosity, right? You start building something, you figure out that there are 10 things that you don't know, you go and learn those 10 things, start applying them in your project, and then you find out there are 20 more things that you want to learn, right? So a good project is the way I would define a good project is that if you start with that you have 5 questions that that you think you don't know. Okay, these are the 5 topics that I don't know. Let me start implementing a project. Say I'm building a chat application, and I know I need to learn these 5 things to implement them, right? I would call this chat application a good project if you start with 5 sets of questions, you learn them, right? Whatever these questions are, you learn them, and then once you are done with the project, you have more questions than what you started with, right? So it takes you down on this journey where you're always learning, right? And that's the only way to supercharge your career, right? So any good project would be, you start with 5 sets of questions. Like, if I just take an example of a chat application, right? So you're starting with chat application. You don't know how to do network communication. You don't know how to make the UI for, say, like an Android app. You don't know how to store data locally. You don't know how to show push notifications when they show up. So let's say you started with these 4 questions, right? And you start tackling them one by one, right? Like, how to do networking, you read about it, implement it in your project, right? So now networking is working. Then you read about how to implement push notification. When a message comes in, you want to show push notification, right? So similarly, you keep tackling all of these problems, and once you have answer of all these 4 questions, you have a set of another 8 questions that new came out during your search and discovery process, and now you're trying to answer them as well, right? Because there's so much knowledge today in the world that there is no end to learning, right? And ideally, that's what projects are for, right? They make you curious as to, oh, let me go learn this, oh, let me go learn that, and let me apply that, right? And that's how you improve as a developer. So even today, right, I don't know if you've seen, we have introduced the C++ module, but you might have seen, if you've seen any of these videos from me only, right? Um, Sometimes even when I am teaching, right, I end up Googling something as well, because there's so many things and nuances that, no single person can sort of learn and familiarize with, right? So don't be afraid to search what you need, but always be in that mind frame that you need to learn, you need to figure out new things, you need to go discover things for yourself, right? And that's how you want to channel your learning. Okay, good. So, okay, generally, I think if anybody has any questions, I'll not be taking questions in the middle, but just keep putting them down in the chat. And whenever I take a pause, I'll go back and take a look at the chat window, and then we can take up questions from there. So whatever question it might be, just put them down in the chat. All right. Cool. So here also, right now, again, today we'll be focusing heavily on your first sort of C++ game project, and we picked up rock paper scissors as a sort of a simple example to get you started, and we'll try to keep the session to maximum 1 hour, and then have another 15 minutes of sort of question and answers on the top. Okay, cool. So we'll use this website called Repel. I don't know if you guys are familiar with it or not. So repl.it. It's a fairly good platform for doing any kind of coding. It supports a lot of languages, and you don't need to worry about kind of installing any IDs or installing any local software, and you can just get going pretty fast. Okay, so the idea is that you don't even need to create a account, and all I'm going to do is just ship this new Repel. I'm going to select C++ as my language and just to create. That's it. So now it's going to give me a nice window where I can start typing my code in. Okay. So we'll give it just a minute to load up, and from there we'll dive in. Okay, cool. So essentially now you'd notice that, your screen is kind of split up, and the core sort of areas that you want to focus on is, on the left half and on the right half, and we'll just dive into exactly what this is, right? So on the left half is basically your, let me zoom in a little bit so that text is more readable. So on the left half is basically what my text editor, right? And on the right half is essentially my command prompt / terminal. And when I run my program, this is where I would expect to, see something happen, right? So this is like the closest way that without worrying about anything, you can get started by coding something. Again, if you're not familiar, don't worry, we'll just talk about what these are. But first, what we want to do is we want to talk about, how to get even started with, any kind of programming or coding or generally anything, right? So like today, we picked up the project, rock, paper, scissors, right? So I'm sure everyone here is familiar with the game itself. If you're not, just quickly, so you have 3 elements that you can pick from, either rock, paper, and scissors, and 2 players are playing. Both make their choice simultaneously, and naturally, there are certain ways that are defined as win conditions, right? So if player one picks rock, player two picks paper, paper beats rock, right? Similarly, if player one picks scissor, player two picks paper, player one wins because scissor cuts through paper, right? So there are these standard set of rules, and our job today is to implement a basic program that lets us create a rock paper scissors game. Okay, so for folks that want to do some code along as well, just go for create the way I set up. Just go to this website repel.it, and I can share the link in the chat window with everyone. So you can just open up the link, hit new repel, select the C++ language, and you'll have pretty much the same screen. All right. Cool. So while you guys go get set up, what I want to talk about is that the first mistake that I see developers do is the moment they are presented with some problem to implement to code, the first thing that they do is start coding, right? And that's the very first mistake that you do, right? And you'll be asking yourself, like if I'm asked to code a problem, right? If I'm asked to write a program for a particular game or a problem or a solution or whatever, right? You're telling me to write a program, and if I'm writing a program, you're telling me that's the wrong way, right? Like what am I doing wrong here, right? So the thing is that 90% of a developer's job is to come up with a solution. Okay, and you can come up with a solution on a piece of paper. You do not need to code. Okay, coding is hardly 10 to 15% of the job. Okay, coming up with a proper solution is the lion's share of what a good developer does. Okay, and that is where 99% of the companies will be asking you to focus on, okay, in the interview process. Okay, so whether it's for full-time jobs or internships or whatever, the focus will always be on, can you solve problems, can you come up with solutions, and not on, do you know all the possible syntax of every possible language, right? Knowing the syntax and learning a specific language is a piece of cake. Right now you guys might be on your first programming language or your fourth programming language or your second programming language, right? In my 10 years I've spent probably 10 plus programming languages, right? Now it is that I don't need to learn a new programming language because I know logically what needs to be done, and I just need to Google enough to figure out what's the right way to implement this. Okay, so by the time you cross your 10th programming language, you will probably start learning, start to understand that there are certain common pieces. Once you get a hang of those, then you're done, right? Like you don't need to worry about a new programming language. Okay, so while we got started with Repel, right, I'm going to close Repel for now, and we'll switch to the whiteboard. Okay, so all right, hopefully you guys can see the whiteboard now. Cool. Okay, so what we're going to do is, for the game that we want to implement, rock, paper, scissors, we want to first figure out what is the right approach to solving this problem, and then we'll go back to actually coding it in. Okay, so we know that there are three core elements. A person or a player can choose either rock or paper or scissors, right? And then two people are battling it out. Maybe one person is playing against a computer, or two people, whatever it might be, right? But there are two sort of things that are getting compared with each other, right? So either one person is picking rock, the other person is picking rock, then it's a draw, right? If one person is picking a rock, one person is picking a scissors, then the rock wins, right? So we know all these rules, right? Now we need to figure out what is the right logical solution for this. Okay, and for this you do not need any programming language. Okay, so come up with a logical solution for any sort of problem, right? You do not need to know any programming language. Without a programming language also, you can come up with a the core solution. Okay, implementing it again is just hardly 15-20% of the job, right? 80% is actually coming up with the right solution. Okay, cool. So here what we need to do is we need to start defining what are the core steps that we think we need in order to solve this problem. Okay, so we're going to start sort of trying to just jot it down in plain English, and from there we'll try to derive the logic. Okay, so first thing we'll do is we'll say, we'll define that, that there are two players playing the game. One is player one and another is player two. Okay, we'll just call them P1, P2. All right, so now what do I need to do? I need to ask P1 for choice, right? Like we P1, player one needs to input their choice into the system, right? Once this is done, then I need to do the same thing with P2, right? What their choice is, right? And they'll enter either rock or paper or scissors, right? Can you guys see the whiteboard? Can everyone see? No? Okay, give me 1 second. Yeah. Okay. Okay, cool. So once once you've taken player one's choice, once you've taken player two's choice, now the next step we need to think about is that somehow we need to uh, match these two, right? So we need to do some kind of a matching on player one's choice and player's two choice, and based on that matching is how I'm going to say that whether player one won the game or player two win the game, like who won the game. Based on this matching, uh, you know uh, I need to sort of declare the results, right? Like who won. Okay, so that's essentially all I've done. Is I've broken down the problem into sort of smaller steps here and just thinking logically about it, right? Like I'm just trying to solve in my head, if you and me were playing this game, how would that go, right? I'll put in my choice, you will put in your choice, and then we'll compare the two, and then we'll give the result. Okay, whether did you win, did I win, right? As simple as that. No programming, no coding, nothing. And already I have come up with a fair bit of a good solution for it. Of course, there are a lot more things to it, but at least it gives me a nice, good starting point without worrying about anything code related. Okay, and this is essentially how you should be thinking about almost any problem, right? Like 99% of the problems that you come up with, you need to be thinking about, all right, how can I first break it down into these smaller pieces? And this is typically referred to as a top down approach. So you start with a big problem, you break it down into smaller pieces, and then you start solving each individual piece. Okay, sometimes the problem might be this big that even if you have broken down it into smaller pieces, individual pieces would need it to be broken down further. Okay, and we'll look at one more example. So here now we have defined 5 key steps in order to come up with a solution for rock paper scissors rule, right? So you have player 1 and player 2, you're asking the player for choice, you're asking player 2 for choice, and now you're matching player 1's and player 2 choices, and based on this matching you're giving out the result. But what about this step 4, right? Matching player 1 and player 2, right? So this seems to be slightly a complex piece, right? Because there's too much stuff. If you think about, okay, I have a rock, you have a scissor. What if I have paper, you have rock? What if I have paper, you have paper? There's so many of these sort of choices that you need to worry about. I feel like there is more complexity in that one line than in the rest of the pieces, right? Like just thinking about it, right? So let's break it down. And this is what I meant, that sometimes when you start with a big problem, you break it down into smaller pieces. Some small pieces would be still big enough that you need to further break it down. Okay, so what we'll do is we'll start writing on the side here somewhere. So for 4, we'll define further substeps. Okay, so we'll just call them ABC, right? Here, what we need to think about is, what am I trying to compare, right? So I'm trying to compare player one's choice and player two choice. So what are the kind of conditions that I can do when I'm trying to compare these two scenarios, right? So chances are that, P1, chose paper, right? And P2 also chose paper. In that case, I know it will be a draw, right? I mean, both chose paper, so it's a draw, right? Okay, next scenario, I know P1 say chose rock and P2 also chose rock, right? And again, this is also a draw. Similarly, I can do the same thing, but for, in statement A, we have both have chosen paper. Statement B, both have chosen rock. Statement C, again, you can think about the scenario where both have chosen scissors, right? If both have scissors, then also it's a draw. Okay, so first I have defined that I have three conditions under which, essentially I'll end up in a draw no matter what. Okay, now let me see in what scenarios will player one win the game. Okay, so if P1 chose say paper and P2 chose rock, right? So in this case, P1 wins. Okay, and if P1 chose, paper is done. So let's say rock, then what does P2 need to choose in order to P1 for win? So right now we are just defining all the conditions where P1 will win. Okay, so P1 has chosen rock, P2 has chosen scissors, right? In this case also, P1 will win. Okay, and then there's another condition where I'll say, okay, P1 can choose, because remember, this is now going to, just the game logic where we are saying that we know that whatever you choose, you can still win. I know that if I'm a player and I choose rock, paper, or scissor, either of them, there is a scenario that I will win. So that's why I know that there are three conditions for P1 to win, depending on what P1 chooses, right? So if P1 chooses scissors, right, and then P2 can choose paper, in this case also, P1 will win. Correct? Okay, hopefully there's no confusion. If there is, just please leave a note in the chat, right? Cool. So now I have defined all the draw conditions. I have defined all the win conditions for P1. Let me define what are the win conditions for P2. Okay. So if I want to think about what are the win conditions for P2, essentially they're the same as the win conditions for P1, except the choices are reversed. Correct? So if, I can repeat all of these three, just replace P1 with P2, right? And then P2 would win. Okay. So these conditions for P2 to win, G, H, and I, right? These are nothing but mirror images of these three conditions, right? So they're nothing but mirrors, right? I'm not repeat typing the whole thing, but it would look something like this if I have to do one, right? I would just say that P2 chose this thing, P1 chose this thing, and naturally P2 won, right? You can do the same logic, and you'll get all the sets of conditions in which either P2 is winning or P1 is winning. Correct? Let me just do this quickly. Okay, so this is how we have taken a bigger problem, right? So we started with our main problem. We broke it down into some essential steps. We realized that there is another step that is, still fairly big. And, we broke down the rules of that particular step further down. Okay. Now, all I need to do is come up with a solution, implement it, right? But essentially, before I start writing code, I know exactly what I need to do, right? So even if something is not, like you're not sure about, oh, if I'm starting a new programming language, right? Then how do I need to implement this? Simple steps can help, right? So now you know that you need to do some kind of a matching, correct? So if you're trying to do a matching or a comparison between two conditions, you can simply Google for, okay, in so and so language, how do I need to do a matching or how do I need to do a comparison, right? Or how do I need to check if two values are equal, right? That will give you some way of implementing that solution, right? Even if you're new to any programming language, right? And this way, what you can do is now you can repeat the same process for all the conditions that we have listed here, and you have a piece of code written down for this particular thing that lets you evaluate whether P1 has one or whether P2 has one. Only because you were able to break the problem down into smaller pieces, you had clarity as to what exactly you need to implement. Otherwise, you would have learned the entire language and it would have taken you months, and then you would have started coding your first project. So instead, try to implement a project, break it down into problems, and start learning about what you need to apply to this problem. Okay. So that gives you more sort of hands-on learning experience rather than your theoretical learning experience. Okay, cool. So now that we have this, let's switch back to our code editor. All right, cool. So I'm just gonna quickly, define the same things. So here as well, I'm just copying it. I'll go over, what I'm doing here in a minute as well. But we need to take users, input, and from there we need to do the comparison or the matching, right? And then we need to declare results. Okay, so essentially what we had broken down on the previous screen, I'm just concising it down into sort of 3 steps. This is the step that we broke further down, right? So we broke this step further down into a lot more smaller pieces. Okay, cool. One second. All right. So now, again, now we'll start talking about C++. All right. So essentially, C++ is a sort of a very powerful programming language. And I know there's so many more sort of modern programming languages. You have Kotlin, you have Java, you have, C Sharp, Go, Python, R. Like the world is full of programming language, and there's probably a new one getting created even right now. So the thing is that C++ is still very popular in the world, right? Like a lot of Facebook's core infrastructure, right? Like the very core component in that powers, all the core engine inside Facebook is still written in C++. I think Quora's core services are still written in C++, right? The reason for that is that it's a very powerful language that gives developer a lot of power in terms of how they want to control the language itself, right? Like it lets you control a lot of things. So while learning Java, learning C Sharp, learning Go, and learning Python is a lot more easy, right? But when you talk about these really complex systems, right, where performance is really key, you cannot implement a lot of things with these programming languages because they take away a lot of complexity. So C++ is still, it might seem that C++ is almost like a dead language that, a lot of people are asking for JavaScript and Python and whatnot, but a lot of the big companies are still today, the core engineers and senior engineers are still working on C++ as the core programming language. Okay. And especially with the rise of, IoT, right? A lot of, embedded systems and smart, devices, these are using C++ as also a core programming language. Okay. So there is still C++ is still very relevant from an industry perspective. Okay, cool. So here's a basic setup for C++, and we'll start sort of breaking individual components of these down. So if you look at the very top line, I mean, these are the things that we added. And the very first line, that when you hit new REPL, there is something called as this hash include IOStream, right? So what this does is, we'll not go too much deep into it, but in order for you to understand what this line is doing is, it's giving you certain functionality that is available by the language itself, right? So you don't have to implement everything from scratch, and you can use certain features that the language provides, and you can start getting to write your code faster. Okay, so it's just giving you that extra support. Okay, over time, as you progress through your C++ modules, you'll start learning more details about how exactly this is, and what exactly this IO stream means, and things like that, right? But for today's sessions perspective, just understand that this is helping you enable certain functionalities that otherwise you would have to do a lot of coding in order to get it running. Okay, cool. uh, what you see here is essentially what you call as your main function. Okay, so main is the name of the function, right? And essentially anything that you put these kind of brackets around is a function. Okay, and function is essentially nothing but a piece of code. Okay, a piece of code that either you will call, or when you run the program will call for you. Okay, and main is a special kind of a function. Okay, it's the starting point of any C++ program. All right, so essentially when you run a program, when you say I'm running my program or I'm executing it, right, that the program starts running from wherever it sees this main. Okay, the main function is the first thing that it starts running. So your entire program, the code for the entire program, will start from the main function. Okay, and function is nothing but this kind of a block. So you can create your own functions. Main is a inbuilt function that you need to have in your program. Okay, so I could do something similar where I can say I can create a function by the name dummy, right? And I've just created a function by the name dummy, just that this function does not have any code in it. I have not written anything inside it. Okay, but this is user defined function. This is something that a programmer has defined, I have defined, right? And if I want to run this function, I would simply, inside my main function, I would simply just do the name followed by the parentheses. Okay, so I'll just move this up here before this so that there's no error. So the function that you need to call should be before, in the number, like it should appear before in the sequence from top to bottom. Okay, cool. So this is a user defined function. Main is a inbuilt function, and your program always starts running from the main function. So we'll just remove this for now, and we'll come back to functions later. Okay, so now we have this main function. Int refers to an integer. It's a keyword, right? As you can see that int is highlighted in a different yellowish kind of a color, sorry, blue kind of a color, right? Because int is a keyword. And what this is defining is that you're expecting this function to, somebody's calling a function, like we called a function from, like we created a dummy function, we called it inside main. Somebody, whenever they call a function, they can expect that the function will return them something as well, some data or something, right? In this case, the program expects that int will return the main function will return some kind of an integer. Okay, so that's all that represents. Integer is just int represents, it's short for integer. It just represents numbers. Okay, and we'll talk more about data types as well. So here essentially is, in one statement, if you want to summarize what's happening on line number 10, is that you're telling the program that you want to see an output or see a message on the screen by the name, or what you want to see on the screen is this text called hello world. Okay, so I'll just run this, so you can just run your program by this run button, and you'll see the output here, right? So you see exactly what was written here, right, gets printed out here. Okay, if I make some changes here, let's say I add in a few some special characters, and I run my program again, right? Now you just see those special characters. You no longer see the hello world. Okay, so I'll just undo it for now. And if I modify this string, I run it again, you'll see that now the new modified string shows up, right, with a bunch of these exclamation marks. So whatever I'm putting here will show up on the screen. Okay, now how does that work is, there are two things to understand here. One, this std cout is a standard sort of an object. Okay, std stands for standard. It's like the short for standard. Cout means output on the console, right? That's how you want to kind of think about it. So you're saying to the computer that, hey computer, take whatever message is written here, right, and look at the direction of these arrow. The arrow is pointing towards the left. Okay, so you're saying take this string or this message and put it onto the cout. Okay, and cout, whatever you give to cout, right, it will just write it onto the output screen wherever it's trying to output. Okay, so far so clear? So essentially we are just saying that whatever is in the message, put it out onto the screen. But you might have noticed that we have something, these last two characters, we don't see them here, right? So we've seen only the hello world and we have seen the exclamation marks, but we don't see anything like these two characters. So what's up with that, right? We see everything else. If I put in some hello world again, and I run this program again, now you'll see hello world twice, right? So you see hello world, bunch of exclamation, and then again a hello world, but you still don't see these. Okay, so this is basically a special character. So what this is doing is that it is telling the computer that, hey, whenever you see this \n, right, anything after that comes in the next line on the output. Okay, so if I remove this \n from here and put it here, right, now before we moved the /n, you saw everything sort of show up in a single line, right? But if I run this program now, so you'll see first part of the hello world will show up on one line, and the next part of the hello world, again the second hello world, will show up on the next line. So essentially this is also referred to as a line break. So we are breaking the current line and moving the output to the next line. Okay, hopefully so far so good. So essentially what you're saying is, hey computer, take this message and transfer it onto the out object. If anything is not clear here, right, I'm of course today the session is slightly shorter. You can go and check the introductory, couple of other introductory videos on C++, and from there you'll be able to sort of go more deeper into, because I've taught about these topics in slightly more depth there as well. Okay, Kshitij is saying I can't hear anything. Is anyone also facing issues with audio? Okay, then it might be some network issue, Kshitij. Just please check. Cool. So yeah, so like I was saying that you can look at some of the the introductory videos that are set up here, and again, like right now I'm moving a little bit faster so that we can start implementing our actual code. Okay, cool. So this is how we'll typically go about implementing a simple output onto the screen. Okay, now this is about just taking an output. So imagine now I'll start talking about the game itself. Okay, what we'll do is, first thing we want to ask the user to input their choice. Okay, so for that, first thing we want is we want to give the user a message that player 1, please enter a choice. Okay, and in brackets we can say rock, paper, scissors. Okay, so we're asking them to make a choice between rock, paper, and scissors. So I'm going to remove the hello world statement because we don't need that anymore. Okay, so now if I run this program, I'll just see a statement saying player 1, please enter your choice, rock, paper, or scissors. Okay, now there's a new problem. So we've so far gone ahead and given an output to the screen, right? We have given a message so that the user can see that we are asking them to enter their choice, but we don't know about how to take the input from the user. Okay, so now we'll learn how to take an input. So as you can expect, right, there is something, if there is something to output to the screen, there should be something matching, or on at least on similar lines, that is taking an input from the screen. Okay. And the standard sort of approach of doing that is through the cin keyword. Okay. So essentially what you're saying, that now take some input from the user. Okay. As you can expect, here we were saying that take this and put it onto the output, right? Now we're doing reverse. We're saying take whatever user has written on the screen, and then you can put it onto, or put it into, or bring it into my program, right? So as you can see, the direction of the arrows gets reversed. So now I'm taking something from the user and from the screen and bringing it into my program. Okay. So what we need to do is that, let me check in my chat. Just need to give my group information. Check. Okay, so seems like some issue with the voice there. All right, cool. So, okay, so moving back here. So what we need to do is we need to now take some input from the user. And for that, we're going to be using the standard cin kind of a statement, all right? And this will let us read input from the user. But in order to read the input, right, we need something to hold this input as well. Okay, so far we have just given it a message and we have been able to display that message onto the screen. But when the users enter something, right, we would need to hold on to it, right? Because we need to do the same thing for player 2 as well, right? So we'll make the same request to player 2 to enter their choice as well, correct? And then we'll have to hold on to it as well, whatever player makes the choice. So when you want to hold on to some data, that presents a new problem, okay? Which is, how do I hold on to some data? In this case, this data is coming from the screen or the user. It might come from some other place down the road, right? We don't know. But all we know is that now we need to figure out how to hold data. And for that, we need something called as a variable, okay? And what is a variable? Essentially, we are saying that we're going to define some space in computer memory where we're going to store some data. Okay, so here I'm going to say player 1. Okay, so what I've done in this statement is that I have created a variable called player 1. Okay, and this will allocate some memory, right? Some memory will be saved where whatever data I want to store will be stored in that memory location, and I can anytime refer to that data by the name variable, by the variable name player 1. Think of it as like a box, right? So if you have a box, you can store things inside it, right? Anytime you want to take things out, you open the box, right? So a variable is nothing but a box, and what you write next to it defines how big or small the box is. Okay, so when you say character, you're saying that the box is one sort of byte big. Okay, if you define this as an integer, right? If I created this as an integer, then it is double the size, so I can store double the information. Okay, and it's giving you a basic idea of you can store big information, small information, etc. Okay, but here what I need is I need the user to enter something like an R, a P, or an S. Okay, and that's, as a result, I need something called as a character. So we already talked about what's an integer. Char is short for character. Whenever I want a user to enter a number, sorry, not a number, alphanumeric value, value between say A to Z, right? That's where essentially I want to input a character. If I wanted this as a choice, right? Press 1 for rock, press 2 for paper, press 3 for scissors, right? Then I would have done something like an int. Okay, but here I want to do a character. All right, so what I'll do is I'll say player 1. So what I'm doing is that I'm asking the player to enter a choice. When they enter one of these three inputs, then I'm gonna store it inside my variable called player1. Okay. Now I need to repeat the same process for player 2 as well. But before we do that, let's quickly verify that what we have written the code till now is actually correct or not. Okay. So what I'm going to do is I'm going to simply output, what player one's choice is. Okay. So this will introduce you something new. Okay. So here I've written that player one, enter your choice. Then I'm reading that choice into a character variable called player one. And just to make sure I'm here, I just want to show it onto the screen as well. This is just for testing purposes, right? So that I know that my program till now is running fine. Okay. So what I'm doing is I'm saying player one, you enter your choice. And from there, I'm just, displaying the choice. So all I've done is I've taken a message that I want to see out, right? And added the player choice that I have just received from the player. Okay. So this is how you can attach two sort of messages together. One that we read from the user or we got from the user, and one which is our own message. Okay. So let's quickly run this and make sure that things are looking good. So player one, enter a choice. Now it is waiting for me to enter a choice. Let me press S and enter. And here it tells me that player's choice is S. Okay. So looks so far so good. So I'm just gonna mark this with a double slashes. So double slashes indicates that this is a comment. Okay. And comments are essentially, pieces of code that are not treated as code. Okay. They're just written as sort of, statements that get completely ignored by the program. As you can see that they get grayed out. It's only when, when you don't need a piece of code, you can just kind of, comment it out, etc. Okay. So now what we'll do is we'll just create matching pair of logic for player 2 as well. I'm just gonna copy and paste the whole thing so that we can quickly do the same logic. And yeah, and that pretty much covers my basics. Okay. So now what I've done is I've implemented a very basic logic that does step one. So my step one is done. I've taken the input from the user. Okay. Both for player one and player two. Okay. Now comes the hard part, which is the actual comparison / the matching logic, the ones that we broke down into sort of a lot of steps, right? So here we need to do some kind of a comparison, right? We said we were doing some kind of a matching and we are checking for player one and player two and their values. Now in any programming language, right, like irrespective of which programming language, the standard steps for doing any kind of a comparison is a if statement. Okay. And essentially it's a conditional statement. And what you're trying to say here is that, you write an if, then there is some condition, will define what this condition is. And, you'll see that these brackets and these brackets kind of match. Okay. And the reason for that is that anytime you're defining a curly braces, like an opening curly braces and a closing curly braces, that just defines a block of code. Okay. And similarly for if statement as well, which is a conditional statement, you're going to define some block of code that if some condition is true, right, then you run this block of code. Okay. And else, you run some other piece of code. Okay. But imagine that you have a lot of conditions, right? So you can chain them together as well. Okay. What that means is that you can say something like else if, right, some other condition, right, and then do this. So if this condition is true, right, then it will start executing whatever is in here, right? So if I write some code here, it will start executing that code and then it will skip all of these. Okay. So it'll start with if and it'll go to else if and then it'll go to else if. All right. Okay, let me quickly look at the chat. Kshitij is asking, is this just the basics, right? Yeah, absolutely, Kshitij. So we're just focusing on the basics today. Okay, Okay. Right. So it looks like rest is regarding the mic issue. Okay, cool. So any questions so far? I'm guessing you guys are good because I don't see any other questions in the chat. But in case I missed something, just let me know. Okay. Uh, cool. So essentially, what I'm going to do is I'm going to define one type of a condition that will give me a basic idea of what is happening in the entire game. Okay. So I know my player one and player two. If I go back to the conditions, right? Um, if my player one, was a rock, uh, essentially what I'm doing is I need to first check whether player one, the information stored in player one variable, if that is a rock or a not. Okay. And the way we do that is by using a double equal to statement. Okay. So double equal to with, the actual value tells me that is player one's value equal to, the capital letter R. If, basically if this condition is true, then this if becomes true. Okay. So if player one's value is R, okay, which means it represents rock, then execute this piece of code. Okay. So that's how typically you go about writing a very simple if condition. Okay. But today we need slightly more complex if condition, right? Because remember, if you think about what we wanted to do was we wanted to check player one is a rock, player two is also a rock, then it's a draw, correct? So if player one is a rock, player two is also a rock, right? Then this should result in a draw, right? But there seems to be some error, right? So we're getting some error. We can see that with the sort of a squiggly line under your player character because we have not written the if condition correctly anymore. Okay. So we are writing two conditions. One is that player one is a rock, and the second condition is player two as a rock. So whenever you're verbalizing these conditions, right, like whenever you speak, just in plain English or Hindi or whatever, right, you're saying player one should be a rock and player two should be a rock, right? There is an and in between. So you need to have that and in your code as well. Okay, because these two conditions need to be true together in order for the game to be a draw. Okay, so in that case, what we have to do is we have to add an and. Okay, so an and in C++ is represented by a ampersand. Okay, a double ampersand in case of a if, when we are doing it inside the if statement. Okay, so if both enter a rock, then it should give out a draw. Okay, so here we will quickly add a cout statement. The game is a draw, and we'll just give a /n, and yeah, good. So for now, let's just comment this code out, right? And quickly test first that, is this code actually running? So this is something that you need to get into a habit of. As you are building your code, write small parts of it and start testing it so that if there are any problems, you'll be able to figure out early, right? If I write the full piece of code, then you'll have much more headache by trying to figure out where are issues and why is something not working correctly. So you want to write small parts and test them often. So I'm just going to quickly run. I know my code currently runs only when there are both the things are R, right? Like both the players have chosen rock. So I'm just going to intentionally put rock in both the choices, right? And make sure that the code runs correctly. And yes, it gives me that the game is a draw. Okay, cool. Now we need to replicate the same logic, but just with different choices. Okay, so all I'm going to do is I'm going to add an else if condition, like I was explaining here earlier, right? An else if condition in which my players have made another choice, but there's still a matching choice, right? So both the players selected paper, right? In this case also, it's essentially nothing but a draw, right? So I'm just going to quickly format this code. Okay. So here also I'm saying that player one has chosen paper, player two has chosen paper as well. Then also it's a draw, correct? And I'm going to just copy this again because we have one more condition where it could be a draw, where both have chosen scissors, correct? This is also a draw. Good. So what I'm going to run, and now I'm going to again run and test it. So I'm going to say player one has chosen P, player two has also chosen P, and now the game is a draw. Okay. So I can run this again and test it. As long as I'm putting in the same value for both, the game is a draw statement will come out. You can test it out. Okay. So what you might have seen here is that essentially we are comparing player one and player two to the same value, right? Both need to be R in this case. In this case, both need to be P. In this case, both need to be S. Okay. Because you're seeing this sort of a pattern repeat, there is something that you can make out of it logically, right? So what you can do is you can say that what if I just directly compare the two values itself, right? What if I compare the two values? In that case, if both the values are matching, right, then I don't need to write all of these three if conditions. Okay. So what I'm going to do is I'm writing it down for now. We'll compare the two logic. Okay. So I'm just saying player one is equal to player two. Okay. So what I've done here is that I've defined that if my player one's value and player two's value is the same, then it's a draw. The reason for that is that if you think about the game, it doesn't matter, right? If you are choosing rock and I'm choosing rock, right? It's a draw. If you're choosing paper, I'm choosing paper, it's a draw. But when it's a draw, it doesn't matter whether we chose rock or paper, right? The outcome is still a draw. So I don't need to write this entire big logic. I can compress it down with just the small logic. Okay. If I did care about that, whether somebody chose a paper, whether somebody chose a rock, right? Then probably I would need to write this. But for the rules of rock, paper, scissors game itself, it doesn't matter, right? The game just starts over again, right? You can continue playing as much as you want, right? A draw is a draw. So all I need to say is that if player one and player two both have chosen the same value, right? Both have chosen either the P or the R or the S, that means their values are matching, then the game would always be a draw. Okay. Hopefully that's clear. So in that case, yes, the first approach we took was writing a lengthy piece of code, but that is absolutely fine. Okay. Because what you need to do is once you've written the logic, first step is to translate it into correct working code. So we wrote this piece of code, we verified it, right? Once we have verified it that it's working, now we are seeing can we, make some improvements to it or not. If you can make it some improvements, great. If you can't, that's fine. Okay. But important thing is to get the correct output first. If you cannot get the correct output and you get stuck in trying to make improvements, those improvements are meaningless. Okay. So having the correct output is more important than having an improved piece of code or a better piece of code, right? So don't try to write fancy code if you know even some fancy language, right? Or sorry, fancy syntax in a particular language. You just need to focus on, first writing code that works. Once you have done that, then you can focus on improving it. All right. So now we have written this. For now, we'll just comment it out so that it's still there if we ever need to refer to it. Okay. Cool. Seems like there's some messages in the chat. Let me look. What if player one gives input K? Kshitij is saying, why can't we just use player one is equal to, okay. So I think that's exactly what I did. What if player one gives input K? K, oh, you mean wrong input. Okay. So Vikramaditya, that's a great question. We'll just come back to it. should not be permitted. What if player 1 gives input k? He will come to that case 2, I think, later on. The choices are only this. You can't handle anything else wrong. Yeah, so I think the sort of discussion was happening is what happens if I run this program, right? And say one person enters, the correct choice. Oops, sorry, let me run this again. So one player enters the correct choice, and the other player enters something like a incorrect, input, something like k, right? In this case, the program is just not doing anything. Ideally, we should detect this, that the person has not entered a correct choice, and throw some kind of an error response, etc. Okay, so I'll leave that up to, again, you need to do something like an if else statement to implement that and show a correct response to the user. Okay, that hey, you have entered an incorrect input. Okay, so I'll leave that as a good bonus exercise for you guys to implement. Okay, so now we have implemented the first part where we are saying player 1 is same as player 2. Now we need to move on to our next cases, which are essentially defining, when the player 1 wins and when the player 2 wins. Okay, so in this case, again, we will do our first approach where we say if player 1 is equal to rock and player 2 is equal to, so if it's a rock, then a rock will beat scissors, right? So in this case, I know my player 1 will win. Okay, so I'm just going to copy this statement and paste it here and say player 1 1. Okay, so player 1 wins a rock and player 2 gets a scissors. So in this case, the player 1 will win. Okay, so now I can copy paste the whole thing, right? I can copy the entire thing and keep changing the statements, right? So player 1 has scissors. In that case, player 2 has, paper, right? And then another third condition. Because remember, when we were writing our logic, we defined 3 core conditions, right? That under these 3 core conditions, player 1 will win, and then a duplicate set of conditions, 3 again, where player 2 will win, right? But in this case, now we'll look at something even our next level step. Okay, so instead of copy pasting this whole if else logic again and again and defining player 1 1 player 1 1, we'll try to cut the code down a little bit. So what we're going to do is that we're going to add multiple conditions, within the if statement itself. So here we have only one condition, right? Where we are saying player 1 is equal to player 2. If that is true, then do something, right? Here we are taking it one step further where we are saying player 1 has some value and player 2 has some value, correct? Now we'll take it one step even further. Okay, so we'll say that we need to verify a group of conditions. So here we have defined an and. So these two conditions are sort of anded together, right? It's not a word, but we're basically taking condition 1 and condition 2. If this is true, then player 1 has won. Okay, but there is another sets of conditions, right? So if I copy paste this logic, I'm going to quickly copy paste first. So what I'll do is I'll put the entire logic in brackets for now, and I'll just explain why. Okay, and here as well, and here as well. Okay, so I know there are 3 sets of condition under which player 1 will win, correct? So player 1 has the rock and player 2 has scissors, or player 1 has scissors and player 2 has paper. And when player 1 has paper, this one player 2 has rock. Under all these sets of conditions, like these pairs, right? Like pair 1, pair 2, and pair 3, right? If any of these pairs is true, right? In that case, my player 1 has won, correct? So I need to do is I need to, like we defined an and condition between these two, we need to define an or condition between the 3 of them. Okay, so what I'm doing is an OR is like a pipe symbol, the one that's above the enter symbol, right? So here I'm saying is that this condition or this condition or this condition, if any of these three conditions is true, then my player one has won. Okay, so far so good. Okay, so because I want to make sure that these two conditions are together, I've put a brackets around them. Okay, they both need to be true because they are joined through an AND logic, right? Like there is an AND between the two, right? If this is true, right, and this is false, and this is also false, still the entire if condition is true, correct? Because player one has chosen um, scissors and player two has chosen paper. Okay, so this is how we have kind of done what we did with the AND logic. Now we have learned about the OR logic. Okay, so now we have defined an OR condition. Okay, any questions? So now we need to replicate the same logic for player two. In this case, all I'm going to do is I'm going to change 1 with 2 and do 1. And now I'm going to say, in this case, player 2 has 1. And that's it. Okay. So within a very short piece of code, I've been able to define whether my game is a draw, whether player 1 has 1, and whether player 2 has 1. Okay, and I can change the order of conditions as well, right? Here I've written conditions in certain specific order. What I can do is I'll just copy it so that you guys can compare. Okay, so I could have done something like make this as my first condition check. So I could have done something like if this, cut this and move it here and make it else if. Okay, so I could have done this very well as well. Okay, so this will also run absolutely fine, the same as the above one. The only thing I'm doing is that first I'm checking whether player 1 has won, whether player 2 has won the game, and then last I'm checking whether it's a draw or not. Okay, Kshitij is asking, can we write else player 2 has won? Actually, Kshitij, no. Yeah, so okay, so before we get into that, what you can do is, so hopefully these two sets of conditions, we've just changed the order of if and else, right? That's all we have done, but the logic is still the same. Okay, in certain cases the first logic might work better, in certain cases the second logic might better, but the point is that in both cases you will get the correct output. Okay, so let's try to run this. Give it 1 second. Repel is reloading the page. Okay, so let's remove this. All right, so now before we go forward, let's just run this program and make sure that the output is coming out correctly or not. All right, so here let's say we say player 1 has chosen S, player 2 has chosen P, so scissors and paper. So we expect to see the output of player 1. Okay, so player 1 has 1. Okay, so let's run this again. Okay, so this time let's add scissors, or rather let's do rock, and let's do paper, so that now we can see player 2 has 1 or not. Okay, so okay, player 2 has 1. So this way you can go in and make sure and test that all the conditions are working as expected. Okay, cool. The player 2 will always win, as player 2 can see the input of player 1 and can enter the input accordingly. So great question. The point is that here you're trying to just create a program not a proper game, but you're trying to create a program that implements or rather that shows the workings of a tic-tac-toe game. Okay, so the next step, I'll share the this link with you guys, and your sort of practice sort of homework experiment is to implement so what we have implemented is a player versus player, right? So we have implemented, so I'll just remove this as well. So we have implemented a player versus player mode, right? What I want you guys to implement is a player versus a computer mode. Okay, so player enters a choice, computer randomly generates a choice. Okay, and then you try to compare the two. Okay, so instead of taking two choices both from the user, you just need to compare the two. Okay, one is a computer generated choice and one is a player generated choice. Okay, how to randomize choice, that's for you to figure out, right? That's the fun part of learning anything, right? So one thing you will see is what we personally encourage, and if you've even attempted any of the MCQ questions or any of the C++ array project based questions, we don't spoon feed people, right? Like that is one thing that we absolutely do not do. Okay, we'll not tell you 100% everything, right? And the reason for that is, when you're given a textbook that, hey, this is the textbook, go learn from this, right? What happens is that you restrict yourself to the textbook because you know that your teacher told you to read from this textbook, right? But intentionally what we do is we teach you 80% or 85%. And then in MCQs, you'll start seeing these terms that you would have never heard about. And that's why we never put time limits on doing MCQs during our entire program as well, right? Like people who are enrolled in a 6-month, 9-month program, they know all about this stuff. But the point I'm trying to make is that we, by design, put certain questions in MCQs that are connected to the topic that you're learning and implementing, but we would have not told you anything about it. Okay, because when we are reviewing your projects, when we are reviewing your code, you are supposed to use those concepts to implement pieces. Okay, so it forces you to go out, Google, learn by yourself. While you're doing this, you might be Googling one term, you learn 10 new terms, right? And that's how essentially people learn in a work environment. So what happens when you enter a tech company, right? When you enter into a tech job, what happens is you don't have a bloody teacher sitting on top of you who's teaching you for 2 hours straight what you need to learn, right? That doesn't work in the real world, right? You'll be thrown into new problems, new languages, new frameworks, and your mentor or your sort of senior engineer, your project lead will tell you, hey, you have 2 days, figure it out, right? So you need to take direction and take what you need to do in a goal oriented manner. Your goal is to maybe do a small experiment with a new framework that your company wants to try out. Maybe your goal is to experiment with some new language that they're experimenting and seeing whether we should move from our existing language into this new language, right? So you'll have to go and learn things on your own, and there will be constraints put on you in terms of time, in terms of what all you can do, etc., right? So now you need to learn them wherever you're getting stuck. If it's a good company, if you have a good team, there'll be seniors and people who will be guiding you, but do not expect that they'll be spoon feeding you shit, right? That's just not how the real world works, right? So problem with the way we are getting taught in our BTech degrees, and I graduated from Delhi College of Engineering, right? And I openly say that we didn't get any good education, right? The reason for that is we are not taught in the way industry expects us today. Okay, and the reason we are doing these kind of project based learning environments is it forces you to go out and learn for yourself, and we intentionally give you resources, external resources, not just our but external resources, where you need to go out and learn. Okay, so there is no textbook for life, right? Like you need to go figure out things on yourself, and the sooner you get into that habit, right, that's the best thing. So the standard problem that is like so you asked me, somebody asked me right now, how do I randomize, right? That's a very good question, because I just presented a problem. Naturally the first question comes to mind is, okay, how do I do that, right? But before you ask me this question, or before you ask anybody on the teaching staff here, right, they'll ask you 10 questions. Did you Google? right? If you Googled, what did you find out? Okay. If you found out, did you implement it? Okay. If you implemented it, what was the result? Okay. If you did not Google it, why not? Right? If you implemented it, then what was the result? And were there more issues? If you found a new error, if you found some new problem, did you Google that as well? Right? So we'll keep asking you these, recursive questions, which will force you to learn, force you to figure it out, right? And that is the mentality and the framework that you need to build. That no matter what the problem, I will figure it out. Okay, and that's the only sort of recipe for success. So cool. So I think that gives you a good sort of an overview of how to think about problems. Okay, I think there was one more question that I think I missed. Somebody asked regarding something around STD. Why are we using STD something, right? Forgot if that was a question. Can somebody type it again, because I don't see it in the chat. Okay. Okay. Anyways, I'll just quickly repeat because I remembered. So the point was that, remember at the very top, we said that we are importing, or rather including, as the word says, right? We are including some inbuilt functionality that is available within the language itself, right? And we need this on demand. So IOStream is giving us access to this C out C in that sort of lets us, interact with the terminal or the command prompt. Okay. And STD is just the namespace. So there's a technical term called namespace under which all these sort of objects and classes are defined. Okay. These are all new terms. If you're new to any object oriented programming language, don't worry. Just go through the C++ video. All the videos sort of talk about, these things in detail. Today we are short on time, so I'm not going into the details, but all these terms are covered there. And this lets you kind of refer to certain things from certain specific locations. Okay, so it's just a shorthand way of writing, sort of similar logic. What happens if you don't use? You can try, right? Like there's nothing stopping you from trying. So you can simply do something like C out, player one, right? That's the shortest C out statement that you can write. And as you can see that it is not able to find what this C out means. And it's smart enough to even recommend you that, did you instead mean STD out? Okay. So it's just for now, just understand that this is a standard way, and you look at other ways of cutting it down. So you can write something like this, but again, I'll let you figure it out, how you can get rid of the STD keyword. If you're not familiar with it, it's a good thing to look at. I think I've mentioned it's in some of my videos that are part of the C++ setup that we have. Okay, cool. So hopefully, this was sort of a fun interactive way for you guys to start thinking about problems, start thinking of projects, and start learning something. If there are any questions related to this today's sort of class implementation, etc., feel free to just put them up in Discord. Me and the other TAs and the other faculty members are usually also around. As most of you might know, that we are kicking off a new batch, and that's starting over this weekend itself. So if anybody is interested to know more details about it, just talk to Satam or Gaurav on the on my team, and you can reach out to them either via Discord, WhatsApp, emails, admissions@the rate, etc. as well, right? So you can just reach out there. What happens if we don't use STD? Error. Yeah. So cool. All right. Any other questions, guys? Oh, I think there was one more condition, right? Somebody was asking what happens if we enter like K or something, right? So one thing that you can think of is that here you're entering, the input from the user, right? So you're trying to say RPNS, correct? If you can check if player one's input is anything apart from RPNS, right? If it is matching RPNS, then you can just directly, ignore it and give a, C out statement that player one, please enter the correct input or something like that, right? and you can do the same thing for player 2. But if you think about it, there is a sort of a shortcut way as well, right? So here we have said we have checked for player 1 and player 2 conditions. Here we have defined all the conditions for player 1 and player 2, right? Here we have defined all the conditions for player 1 to win. Here we have defined all the conditions for player 2 to win. Okay, what will happen if none of these are true, right? You end up in a final statement, else statement, that will execute if this is also not true, if the second one is also not true, if the third one is also not true, right? So neither it's a draw, nor player 1 won, nor player 2 won, right? Now this means that there is some kind of an error in your input. Okay, here you don't know, without doing any further checks, you don't know which player made an incorrect input, but you just know that there is an error. Okay, and you can just try to see if you can restart the game. Okay, so this is, you can definitely check here, then you can make a check here, and you can then have a common check here as well. Okay. Kshitij is asking, where do you recommend we can practice this kind of C++ questions? So typically, a lot of times the standard programming websites, right? And there are a couple of good ones. They usually focus heavily on sort of standard questions, right? Like swap two numbers, questions that have very less real world significance, right? And that's typically where, while it is important to practice those questions and over time build your ability to sort of solve logical problems like we did today, right? It is also important to try to implement things that are more sort of real world connected, so that you still have a sense of where you can start working on these. And essentially this is what we are trying to do in our courses as well. Do a lot more on uh, a lot more on sort of real world project based, and majority of the projects sort of revolve around games, because I personally feel like games is the best way to sort of learn things in a very fun sort of interactive environment, right? So uh, typically when you're talking about a game, right, and especially when you're thinking on these games that you already know, right, you don't need to learn the game, right? You already know what rock paper scissors is, you already know what Tetris is, you already know what tic-tac-toe is, right? So we're using a lot of these sort of projects to kind of help you build sort of this understanding of the language, and also push you to implement things your own way, right? Because every programmer tries to implement things this way. Yeah, so Vijit, thanks for mentioning the list. This is actually a very good list: HackerRank, Code Chefs, Code Forces. There's like, you can literally Google and you can find 50 websites that have good sort of database of problems, right? So we have our own sort of internal database that students that are currently enrolled in a program practice, so some 300 plus questions, right? But I always recommend that do not restrict yourself to just these questions. Always go out and try a lot more variety of questions as well, right? Just to become more sort of well-rounded. For these types of specific questions, these are more project based, and I've personally not seen good websites where these things are available, and that's why we are putting these up in our Google Classroom, so that students can kind of get familiar with them, try to implement them, and sort of discuss with the community on Discord if they're running into any issues, right? So that's one of the core reasons why we are so heavily pushing into setting up a lot of things, be it in the free course structure or the paid course structure, etc., right? We're trying to push into these project frameworks, right? Like where you can learn things through projects. And the best part is that when you're implementing projects, right now you would have not even sort of thought about it, but essentially what you did was you come up with an algorithm, right? Like when we were implementing this program, right, we thought of the logic first sort of in just like plain English, and then we implemented it, right? That whole approach is nothing but problem solving in an algorithmic way, right? We came up with an algorithm, step by step approach to solving this particular problem. And the best and the most intuitive way of developing this is through implementing hands-on projects, right? and implementing these puzzle problems as well. So both kind of need to go in hand. If you just do projects, that's also not enough. If you just do standard problem solving, that's not enough. Yeah, you need to kind of merge the two, and that is where sort of the best sort of learning comes out. Okay, so majority of the people that are going through our paid program, right, like even the working professionals, I mean, so they get to interact in a very similar way, where I would be reviewing their sort of code pieces. So typically we have like 10 people, a maximum 15 people in a batch, and every 3 days we meet on a live session like this one, where you'll be given a project or a piece of a project to work on. If you're working on a bigger project that might last say 4 weeks, you'll be given a project, you'll be implementing and reading and matching study material, very much how if you see the C++ setup, right? It's exactly how both game developers and web developers go through. And so if today is our live session, I'll be looking at your code, and our other mentors and trainers will be looking at the code pieces, and we'll be having an open discussion, very much like we did today, right? But it will be just lot more interactive, where I'll be reviewing your code and giving you feedback on, okay, why did you write this? How did you write this? Let's think if there is a better approach, etc., etc. Right? So it basically mimics a very real world, senior engineer, junior engineer relationship, right? And that is how you sort of need to start learning, right? Versus a very sort of a classroom approach, which doesn't work, at least in today's world. Okay. Also wanted to ask, is it better to take an algorithmic approach to solve a particular problem, right? I mean, that's exactly what I was trying to say, right? Like, so first think of logic. Naturally, logic turns into algorithm turns into an actual code, and then you test the code. That is exactly the steps that we took, right? So step one was logic. We first wrote the logic. First we thought of the logic in our head, then we turned it into a small algorithm where we defined step one, step two, step three on the whiteboard. Then we turned it into code, right? And this is where your actual step three coding comes in, right? And then step four was to test it, where now we started adding these error checks and error conditions, right? To make sure that our program runs in all possible cases. So as you can see, out of the entire thing, right, the coding and the testing part is a small piece of it. We spend too much time on just thinking about the logic, because once you nail that down, rest becomes very easy. Okay, cool. Any other questions? So yeah, so I think we can just wrap up. Will the session be posted for future reference? Yeah, so the session will get recorded as well. So by tomorrow, expect to see it up on YouTube as well. All right. So we'll share the link in Discord. Cool. So hopefully you guys had some fun. Again, if you're more sort of intrigued about the sort of this project-based learning approach as well, you can check out. We have a very different kind of a game project set up for you guys, where you're implementing sort of adventure style game. Again, this is kind of set up here in Classroom, and again, all the material is available here itself, along with learnings as well. So what you can do is just go top to bottom sequentially. After you do a specific problem, right? Like after you do a specific learning material, there's going to be a matching problem that you need to implement that will use the concepts in it, and eventually you'll keep incrementing. So the way this particular project works is that this entire thing is essentially one big project broken down into smaller pieces. So in first, you're implementing, say, one specific class. Then you're adding more classes to it. Then you're starting to use those classes, right? And then you're like, by the end of it, you'll have sort of a mini game sort of working, like an RPG text adventure game, right? So that's how we sort of think about, how to implement projects, right? I think the array one is not yet up, but I think it'll come up within the next day or two as well. Okay. Can we get problem more? Shavi, I'm not sure. Sharvi, I'm not sure what you exactly mean. But if you mean like something like this, like the problem's already set up. How long before we move on to Unity? So Unity will be, again, so that's a question specific for game developers. So typically for people who are enrolled into the full program, right? Whether you're in the 6 months version, if you're a senior, or if you're just in college, it will be a sort of a 9-month version of a similar program. So typically think about that data structures and algorithms, the full module along with C++, sort of it goes into very advanced level topics as well, along with sort of a major project on just C++, building a full-fledged game on using every possible data structure that you have learned. That full module is somewhere between 2.5 to 3 months long. Okay. And then similarly, once you have graduated from that module, that's when you start working on the Unity module. And for people who are doing sort of the web development track, they start doing the HTML and start working on the web technologies modules instead of the Unity module. So, but building a core understanding and core of data structures, logics, algorithms, problem solving, irrespective of what kind of a developer you are, this is something you need to understand, that you need to have, right? Otherwise, there's no point sitting in 99% of job interviews or internship interviews. Every company is going to judge you on your competencies as part of these particular core, skill set. How quickly you can come up with correct logical solutions, how accurate you are. If you're given some direction that, hey, you're thinking wrong, what if you think this way? Can you now start thinking in the right way and come up with this, right? So this is how you want to think about it. Okay. So will we be getting certificate as well for? Absolutely, yeah. So once you complete the projects and the modules, like we'll be getting certificates. But again, what you want to think about is that certificates are not the end goal, right? Because by the time you've already finished these projects, your mind will be like, wow, there's so much shit to learn. You'll probably forget asking me that, sir, can I get my certificate, right? I mean, they'll give you your certificate, but you want to get to that stage where you're not even concerned about the certificate because you have the right skill sets to show to the companies. Okay. So that's where you want to get at, right? And today, if you look at it, right, at least the good companies, they'll want to review as a coder. If you're focusing only on development profile, right, they want to review your GitHub. They want to review your code projects, right? They don't want to see a certificate alone, right? If that certificate is like, hey, this is the certificate, these are the projects that I made, great. That certificate has value because then you can show them, right? These are the things that I did. But if you just show a piece of paper or a certificate, right, that's in today's world, it's starting to lose a lot of its meaning, right? So in that case, you want to start focusing on a lot more of things that you can show, right? So even for people who want to go deep into just data structures, algorithms, and competitive programming, having a competitive profile on code forces, code chefs, etc., that is also something to show. It's better than a certificate, right? Because now you're saying that, hey, don't just take what is written on the certificate, but actually go look at my profile that I've built over years, right? I spent 3 years building that profile and I have a gold star on it, right? Or whatever. So, or go to my GitHub profile and see the 56 projects that I've done and the 30 external projects that I've made contributions in, right? Nobody can cheat on that, right? Like nobody can fake it. That has real life value, right? And it shows how much effort and energy you have put into your own skills. Ultimately, that's the true sort of way to define yourself from rest of the crowd. So what kind of companies we can expect to crack? So companies is basically your own sort of goal, right? Like you want to try for such a specific type of companies, great. You want to try for another type of companies, great. But essentially, there is no limit. We have seen people who are working in two-man companies because they love the startup culture. They love getting in early and fixing those problems and building things from scratch. Others want more structure, and this is something for you to figure out what kind of companies you want to work at, right? A lot of people just sort of think about, okay, I want to work with so and so companies because of the package. Sure, that is a good a good starting point, but you want to try to think a little bit more deeper. Why do you want to work for this company? Why do you want to work for an XYZ company? What is the advantage that you get, right? So let's say product based like Amazon. So okay, so I don't want to publicly say something about Amazon. I have a lot of friends and my batchmates that are working as senior managers and project managers and whatnot in Amazon, Microsoft, DShaw, etc. as well. These are great companies, but they also have internal issues, etc. as well. So chances are you might end up on a team that is actually not very fun, right? And I've seen people quit and leave from one company to another because their team was not great. So just don't think that, okay, because people are getting good jobs, etc. as well, from a company that huge as Amazon/Google, you could end up in a smaller team which is not that fun, and you might not enjoy it, right? So take it with a grain of salt. Okay, cool. So essentially what I was trying to say is, yeah, you need to kind of get to that stage and figure out what is the right sort of company for you, right? Some people enjoy small companies, some people enjoy mid, some people enjoy big. It purely depends on a personal taste, but essentially, yes, you can potentially land into any kind of company. You'll have to sort of curate a little bit of learning experience specifically catered to that particular segment, and the whole sort of guidance and mentorship guidance that comes with it is something that is essential to every developer, right? Have you been part of any lots bigger companies? Lots. I don't enjoy big companies anymore. So I started my career with D Shaw, and I moved to Electronic Arts in US as well, but not a very. I'm personally not a fan of big companies. Anyways, you can look that up on my LinkedIn profile. Cool. So I think we have overshot a little bit on time. So hopefully you guys had fun. If there are any questions, just feel free to put them in Discord. I'm usually there to answer any questions as well. And thanks everyone for joining in. Was great interacting with you guys, and hopefully I'll see you guys sort of engaging more with the community, and also maybe some of you will be interested in exploring more of these projects as well. Cool. All right. Take care, guys. Good night.